NFPA 30.1 Section 5.11 states that fuel dispensing installation shall be provided with a disconnecting means that simultaneously disconnects all ungrounded conductors of the feeder circuit to ungrounded neutral conductors. NFPA 30.1 Section 5.12 states that the disconnecting means shall be located at least 20 feet but not more than 100 feet from the dispensers. The NEC code requires a single disconnecting means, such as a contactor or circuit breaker with interlocking, that simultaneously disconnects all conductors. Two switching neutral breakers with a common trip do not meet this requirement as they only disconnect the neutral conductors. Install a single disconnect switch or circuit breaker with interlocking that meets the following requirements. Firstly, it needs to be located between 20 feet and 100 feet from the dispenser. Secondly, it simultaneously disconnects all ungrounded and grounded conductors. As a temporary solution until the building is built, a fused disconnect switch or circuit breaker that meets the same requirements as above could be installed. The temporary disconnect should be clearly labeled as temporary and should be replaced with a permanent disconnect once the building is completed. The location of the disconnect should be accessible for emergency shutoff. The disconnect should be interlocked with the dispensers to prevent dispensing without the disconnect being in the on position. The NEC, or National Electrical Code, is a widely adopted standard for safe electrical installation in the United States. It's important to consult the latest edition of the NEC and local codes for specific requirements and area. The NEC provides guidelines for various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. Its purpose is to protect people and property from electrical hazards. Regarding fuel dispensing installations, the NEC addresses specific safety concerns due to the presence of flammable liquids and vapors. The code aims to minimize the risk of ignition and electrical shock in these environments. NFPA 30A, or the Automotive and Marine Service Station Code, provides additional requirements specific to fuel dispensing facilities. It covers topics such as tank storage, dispensing equipment, and electrical installations. The requirements mentioned in the NEC and NFPA 30 are designed to ensure the safe operation of fuel dispensing systems and to prevent accidents. The requirement for a disconnecting means within a specific distance of the fuel dispensers is intended to allow for quick and easy shutoff of power in case of an emergency. This helps to prevent further dispensing of fuel and reduces the risk of fire or explosion. The requirement for simultaneously disconnecting all ungrounded and grounded conductors is to ensure that the entire electrical circuit is de-energized during a shutdown. This eliminates the possibility of a ground fault or other electrical hazard. Using a single disconnecting means, such as a contactor or circuit breaker with interlocking, is the preferred method for achieving this simultaneous disconnection. This type of device is designed to reliably interrupt the circuit and prevent accidental reconnection. Two switching neutral breakers with a common trip do not meet the requirement because they only disconnect the neutral conductors. The ungrounded conductors, which carry the current, would still be energized, creating a potential safety hazard. Installing a single disconnect switch or circuit breaker that meets the specified requirements is essential for compliance with the NEC and NFPA 30A. This ensures the safety of the fuel dispensing installation and protects against potential electrical hazards. When selecting a disconnect switch or circuit breaker, it's important to choose one that is rated for the appropriate voltage and current for the circuit it will be protecting. The device should also be listed by a recognized testing laboratory such as Underwriters Laboratories or all to ensure that it meets safety standards. The location of the disconnect switch or circuit breaker should be readily accessible in case of an emergency. It should be clearly marked and easily identifiable. The disconnect should be installed in a weatherproof enclosure if it is located outdoors. The requirement for interlocking the disconnect with the dispensers is to prevent dispensing of fuel unless the disconnect is in the on position. This helps to ensure that the electrical system is properly energized before any fuel is dispensed. As a temporary solution, a fused disconnect switch or circuit breaker can be installed until the building is completed. This provides a means of disconnecting power to the dispensers during the construction period. The temporary disconnect should meet the same requirements as the permanent disconnect, including the location, simultaneous disconnection of all conductors, and appropriate ratings. The temporary disconnect should be clearly labeled as temporary to avoid confusion and should be replaced with the permanent disconnect once the building is completed. In addition to the requirements for the disconnecting means, the NEC and NFPA 30 also address other aspects of the electrical installation at fuel dispensing facilities. These include the use of explosion-proof wiring methods in hazardous locations, proper grounding and bonding of equipment, and the installation of overcurrent protection devices. Hazardous locations are areas where flammable liquids, vapors, or gases are present or may be present in the air in sufficient quantities to produce explosive or ignitable mixtures. These locations are classified according to the type of hazard and the frequency of its presence. Explosion-proof wiring methods are designed to prevent the ignition of flammable atmospheres. These methods include the use of rigid metal conduit, explosion-proof fittings, and intrinsically safe circuits. Grounding and bonding are essential for preventing electrical shock hazards. Grounding provides a path for fault current to flow back to the source, causing the overcurrent protection device to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together to create a common ground potential. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level. It is important to consult the NEC and NFPA 30 for specific requirements regarding the electrical installation at fuel dispensing facilities. These codes provide detailed guidance on how to ensure the safety of these installations and prevent electrical hazards. Compliance with these codes is essential for protecting people and property from the dangers of electricity and flammable liquids. The single disconnecting means is designed to be manually operated, allowing personnel to quickly de-energize the fuel dispensing system in emergency situations, such as a fuel spill, fire, or other hazardous event. The requirement for the disconnecting means to be located between 20 feet and 100 feet from the dispensers ensures that it is readily accessible, but also provides a safe distance from the potential hazards associated with the dispensing area. This distance allows personnel to reach the disconnect without being directly exposed to the immediate risks of a fuel-related incident. The disconnecting means must simultaneously disconnect all ungrounded conductors, which are the conductors that carry the electrical current from the power source to the fuel dispensing equipment. It must also disconnect the grounded neutral conductor, which provides a return path for the current. By disconnecting all these conductors simultaneously, the entire electrical circuit is de-energized, eliminating any potential for electrical shock or ignition of flammable vapors. Switching neutral breakers, even if they have a common trip mechanism, do not meet the code requirement because they only disconnect the neutral conductors. The ungrounded conductors remain energized, creating a potential hazard. The preferred solution is to install a single disconnect switch or circuit breaker that is specifically designed to disconnect all ungrounded and grounded conductors simultaneously. This type of device is commonly used in industrial and commercial applications where safety is paramount. The disconnect switch or circuit breaker should be properly sized and rated for the electrical load of the fuel dispensing equipment. It should also be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure that it meets safety standards. The disconnect switch or circuit breaker should be installed in a weatherproof enclosure if it is located outdoors to protect it from the elements. The enclosure should also be properly grounded to prevent electrical shock hazards. A temporary solution of installing a fused disconnect switch or circuit breaker can be used while the permanent building is under construction. However, it is important to ensure that the temporary disconnect meets all the same requirements as the permanent disconnect, including the location, simultaneous disconnection of all conductors, and appropriate ratings. The temporary disconnect should be clearly labeled as temporary to avoid confusion and should be replaced with the permanent disconnect as soon as the building is completed. It is also important to note that the location of the disconnect should be accessible for emergency shutoff. This means that it should be easily reached by personnel in the event of an emergency. The disconnect should not be obstructed by any equipment or materials. Furthermore, the disconnect should be interlocked with the dispensers to prevent dispensing without the disconnect being in the on position. This ensures that the electrical system is properly energized before any fuel is dispensed, and that the dispensers can be quickly shut down in the event of an emergency. The interlock can be a mechanical or electrical device that prevents the dispensers from operating unless the disconnect is in the on position. It is also recommended to have regular inspections and maintenance of the electrical system at fuel dispensing installations to ensure that it is in good working order and that all safety requirements are being met. This includes inspecting the disconnecting means, wiring, grounding, and overcurrent protection devices. Any damaged or defective equipment should be repaired or replaced immediately. Proper training of personnel is also essential for ensuring the safe operation of fuel dispensing facilities. Personnel should be trained on the proper procedures for operating the dispensing equipment, handling fuel, and responding to emergencies. They should also be familiar with the location and operation of the disconnecting means. In addition to the NEC and NFPA 30A, there may be other local codes and regulations that apply to fuel dispensing installations. It is important to consult with the local authorities to ensure that all applicable requirements are being met. It's also worth noting that technological advancements are constantly being made in the field of electrical safety. These advancements can lead to the development of new and improved safety devices and practices. It is important to stay up to date on the latest developments in electrical safety and to incorporate them into the design and operation of fuel dispensing installations. By following all applicable codes and regulations, implementing appropriate safety measures, and providing proper training to personnel, the risks associated with fuel dispensing installations can be minimized. This helps to protect people and property from the dangers of electricity and flammable liquids. The disconnecting means should be installed in a location where it is protected from physical damage, such as being struck by vehicles or equipment. It should also be protected from exposure to corrosive substances, such as fuel or chemicals. The disconnecting means should be clearly labeled with its purpose and function. The label should be durable and weather resistant. The disconnecting means should be inspected regularly to ensure that it is in good working order. The inspection should include checking for any signs of damage, corrosion, or wear. Any damaged or defective parts should be replaced immediately. The disconnecting means should be tested periodically to ensure that it is functioning properly. The testing should be performed by a qualified electrician. The results of the testing should be documented and kept on file. The disconnecting means should be properly maintained to ensure that it continues to function properly. The maintenance should include cleaning, lubricating, and tightening connections. The maintenance should be performed by a qualified electrician. The disconnecting means should be replaced if it is damaged, defective, or worn out. The replacement should be performed by a qualified electrician. The replacement disconnecting means should meet all applicable codes and regulations. The old disconnecting means should be disposed of properly. The disconnecting means is a critical component of the electrical system at a fuel dispensing facility. It is important to ensure that it is properly installed, maintained, and operated to protect people and property from electrical hazards. In summary, the NEC and NFPA 30 require a single disconnecting means that simultaneously disconnects all ungrounded and grounded conductors of the feeder circuit at fuel dispensing installations. This disconnecting means must be located between 20 feet and 100 feet from the dispensers and must be accessible for emergency shutoff. A temporary solution can be used until a permanent building is constructed, but it must meet the same requirements as the permanent disconnect. The disconnecting means should be interlocked with the dispensers to prevent dispensing without the disconnect being in the on position. Following these requirements ensures the safety of the fuel dispensing installation and protects against potential electrical hazards.